Good morning to all. Today we are going to discuss about a CO2 second part. That is, we have already covered greedy method. We have covered divide and conquer. Under divide and conquer, we have covered quicksort and merge sort, Strassen's matrix multiplication. That is the first part of CO2. And now we are going to discuss about second part of CO2. That is greedy method. Under greedy method, we are going to discuss some problems like knapsack problem and job sequencing with deadline, like that. So today in this session we are going to discuss about introduction for greedy method. That means what is a greedy method and what we can do with greedy method, and then along with that greedy method, one of the problem I would like to discuss about job sequencing with the deadline. So now we will see the introduction for greedy method, and then we will go with the job sequencing with deadline. So generally greedy method is one of the optimization technique. So before that, before going in depth to the topic, we have to know about some terminology. That is, what is optimization, and as I said, greedy method is one of the optimization technique, right? So before going to the topic, we have to know about what is optimization. Okay, so I will take one general example to explain the terminology belongs to the optimization and greedy method, so that we can able to go and we can able to understand the remaining steps. Okay, so we will see what is the greedy method. So I will take one example. First, one example I will take. Let us consider if you have chosen two locations, that is A and B. So what is my point here is, I want to travel from A to B. So here the problem statement is, we have to reach the location A to location B. So generally we have, if you have selected two locations to reach that from A to B, we have many solutions. Like, let us consider solution 1, that is by walk. Okay, and let us take another solution, that is by bus, and let us take another solution car, or solution 4 train, or solution 5 flight. Okay, so that these are all are possible solutions to solve the problem. Okay, right? So these are all the normal solutions for the given problem. So now here, what is the difference for greedy method, or what is the terminology here we are going to use is, the problem is we have to reach from A to B, and here I am going to take one constraint here. Okay, that is one condition. Okay, so what is my condition is, I have to reach from A to B within 12 hours. So this is the time limit I have assigned for the problem. This is one constraint. Okay, so we have to reach A to B within the 12 hours. This is the constraint. Without constraint, we have many solutions, that is S1, S2, S3, S4, S5, so that we can have many solutions without having any constraints. Okay, right? So here my constraint is 12 hours. Within 12 hours, I have to reach my destination from A to B. Okay, so let us consider by walk it can able to reach the destination within 12 hours, and by bus not able to reach, and by car not able to reach. Let us consider the S4 is belongs to train, so we can able to reach the destination with train within 12 hours is possible. So we can consider this as the one of the possible solution. And S5, this is considered as flight. Okay, so through flight also I can able to reach the destination from A to B within 12 hours. Okay, so without constraint we have many solutions, but with constraint, when I am taking a constraint, okay, so that constraint following only two solutions. So okay, these two solutions will be called as feasible solutions. Feasible solutions. Okay, so what is a feasible solution is a solution which follows, okay, so which follows the constraints, or which is satisfying the constraints to the given problem. So that solution will be called as a feasible solution. So the solution will be a solution which is not following a constraint, that is a normal solution. We have many solutions for the given problem, but when we are going to take a constraint, only two solutions are there to follow to solve the problem. Okay, so only these S4 and S5 are the two solutions which are following my constraint or which are satisfying my constraint. That means these two solutions will be called as feasible solutions. Okay, right? Then here what is my point is, initial point, greedy method is one of the optimization problem. So now we have to know about the optimization. What is an optimization? So optimization will only work on either the minimum value as output or the maximum value as output. Okay, the main goal of the optimization problem is, for the given problem we can able to give either minimum value as output or maximum value as output based upon the constraints. Okay, so based upon the problem. So for example, so in this example, okay, S1, S2, S3, S4, S5, these are the general solutions for the given problem. When I have taken a constraint, only we have two solutions only, that is S4 and S5. So now what is my rule is, within 12 hours I can able to reach by solution 4 and solution 5. So here I have suggested which solution will reach within minimum time. Okay, within short time, that is S4 or S5. Within these two solutions I have to take which one reach within the short time. Okay, let us consider S4. By train we can able to reach within short time, that is minimum. Okay, so here this solution among all, this S4 solution will be called as optimization solution. When we have announced one solution as an optimization solution, that means that is the best solution. Okay, that is, we can say this is the best solution. We cannot able to take another best solution without this one. Okay, so among all the available solutions we can say S4 is the best one. Okay, so this solution will be called as optimization solution. Okay, this solution will be called as optimization solution. Okay, so what is the problem we have discussed here? Here we have taken a general problem. We have chosen two locations, A to B. A is one location and B is a second location. So the problem is, here we have to reach from A to B. So before that, without any constraints, we have many solutions. Okay, when I have taken a constraint, that is we have to reach the destination within 12 hours, we have only got two solutions, that is through train and through flight. Okay, so these two solutions will be called as feasible solutions. Feasible solution means the solution which satisfies the given constraints, that solution will be called as feasible solution. Okay, so within the feasible solutions, either it may be one solution or many solutions. Within that feasible solutions, we have to identify the optimization solution. Optimization solution means we have many feasible solutions by satisfying the given constraint. Among all those feasible solutions, we have to identify the best solution. Which is the best solution? Best solution means, based upon the problem, we have to select either minimum as best solution or maximum as best solution under optimization. In this case, we have to reach within short time, that is minimum value, minimum time. Okay, so in the feasible solutions we have two solutions, S4 and S5. Now we have to compare which one will reach within the short time, S4 or S5. So here the solution is S4. Through train we can able to reach the destination within short time. That means we can announce that S4 is the optimization solution. Why? Because through the solution S4 we can reach the destination within a short time. That is the minimum value. Okay, so this is a basic example for the optimization and feasible solution and greedy method. Okay, these are the basic terminology we have to know about this one. Okay, and then we have to see, we'll go to the PPT back. Okay, so optimization problems, those for which are objective to the either maximization problem or minimization problem. Okay, for example, we have shown two problems here. The graph coloring problem, that means here within the minimum number of colors we have to fill the graph. Okay, that is the one example under optimization. And next example, shortest path in between two vertices in a graph. Like this we have seen in the general example. I have taken two locations. Let us consider those two locations are two vertices. Within two vertices, we have to identify the shortest path. Okay, as now we have identified the S4 is the shortest path in between A to B. Okay, like that. These are the two examples we have taken to show under optimization. Okay, so we have many examples actually. Okay, and then go to the next next slide. So greedy approach. So greedy contains greedy. This is the example we have taken from A to B. We have to travel. This is the example we have already seen. And then terminology, what is a feasible solution and what is the objective function, what is the optimal solution. A feasible solution is, just now I have explained, which is the solution which satisfies the given constraint, a set of constraints. Okay, that solution will be called as a feasible solution. For a given problem, we have one feasible solution or more feasible solutions. Okay, so we can say that optimization solution is one of the feasible solution. Okay, we have many feasible solutions. Among all those feasible solutions, we have to identify the which is the optimization solution. Next one is objective function. Objective function means here we are considering the condition whether we are going to take a maximum value or minimum value in the feasible solution. We have to pick either minimum solution or maximum value solution. Okay, that is the objective function, and after identifying the objective function, we have to take the optimal solution. We have to select based upon that objective function. We have to identify the optimal solution from the set of feasible solutions. Okay, so we can able to announce one solution as the optimal solution, that is the best solution from the set of feasible solutions. Those are solutions identified as the feasible solutions. From that, we have to pick one as the optimization solution based upon the constraints. Okay, so this is the terminology for feasible solutions and objective function, optimal solution. Okay, and this is the general method for greedy method. This is the algorithm we are going to follow. So here what we are taking here is, here we are taking here one array. Okay, so one array with, so let us consider here A is the array and n is the size of array. Okay, so n is equal to 5. Here I am taking the elements 1, 2, 3 and 5. Okay, so here I am taking the values 1, 2, 3, 4, 5. So in the greedy method, I am taking the input data, one array with size 5. So here these are the input data. Okay, so this is the input data, and then initially the solution set is null. Okay, no solution is there up to now. We didn't identify any solution initially. Okay, so after identifying the solution, that solution will comes under the solution set. Okay, initially the solution set will be the null value, pi value. Okay, and we are using here for loop. Sorry, I am taking. I will erase this. So initially I am taking a for value. For value will be start from I is equal to 1 to n. We have to see. So the input from the array data will be randomly picked from 1 to n. I will see. So what is the data we have picked for 1 to n? We will see take the data. So array 1, this is the element, array 2. So this is the element 2. So here x is equal to select of a. Select of a means from the array we have to select one element randomly. Okay, so we can take any input data from here. Either we can take this 2 as input, 1, 2 as input data, or 4 as input data. Okay, we can select any random data. Okay, if that when you are taking the input data, based upon that input data, if the output will be a feasible solution. Okay, the solution is a feasible. If you identified that, what is feasible? The solution which satisfies the given constraint, that is a feasible. Okay, so here we have choose a select of a, means we have choose randomly the input data from the given array. After selecting the data, what is the solution you have got? If that solution is a feasible, we have to add into the solution set. Okay, so initially solution is a 5 null. Now what is the feasible solution you have identified from the input data what you have taken as x? That x will comes to the solution set. Okay, so feasible solution, if any data any solution identified as feasible, that comes under to the solution set. Now solution initially as 5, that is null. Now x is a feasible, it was identified as a feasible. Now x will be added into the feasible set. Okay. So what are the solutions we have got a feasible? That feasible solutions will be considered as a one set. That data will be added into the feasible set. Okay. So now we have to add, we have to union, we have to take the solution set and updated feasible solution. Okay. What are the solution set values are there, and that a newly added feasible solution will be added here. Okay. So at last the solution will be added. Okay. Among that solution set, that means among the feasible solutions, we have to identify the optimization solution. This is a general method, general algorithm to follow the greedy method. Okay. So this is the algorithm we have to show. So I will erase all this and we will go to the next slide. Now here we can see one example here, that is a counting coins problem. Okay. So what is counting coins problem is here in greedy method what I said is this is the optimization solution. So optimization means it will be used to give the best solution. Okay. So here in some conditions, in some cases greedy method won't work to give as it is the best. So why? Because greedy method will think about the at present situation. For that present situation, it will give the best solution. Okay. So we can say this one. Here we have a coins 1, 2, 5 and 10. So what is the problem here is we have to find out the total 18. So what are the coins we are going to use? We have to sum 1, 2, 5, 10. Now greedy method how it will work is the maximum value will be taken. The 10 coin will be taken first and 5, 2, 1. Okay, it will give priority for the highest value. Okay. So like that we have to take the total, we can reach the total 18. Okay. Now for the next example we can see here let us consider we have coins 1, 7, 10. My target is 18. What is the highest value? Greedy method will works with highest values first. It will give preference for the highest coins. Okay. So 10 will taken first and 7 and 1. So 10 plus 7 plus 1. For the same coins we have seen next example we have to take the total 15. Okay. So greedy method will work the maximization coin first. So the highest value have 10. So 10 will be taken first and 7 we won't take. Why? Because my total amount is 15. So if I have considered 7 also it will cross. So 17 I won't so I want to take I don't want to take a 7. So next one. So 5 1 coins we have to consider. Okay. This will be explained here. This is the solution. 1 10 coin plus 5 ones coins we have taken plus. Okay. So this is a, but when we can say this is the best solution means less number of coins. When you have used less number of coins, that solution will be best. But for this case 1, 7, 10 we have taken the coins and the total amount is 15. How greedy method will work is 10 plus and 5 coins will be taken. Okay, that is 15. So but here more number of coins we are using. For with the same coins we can able to give the solution, that is 2 7 coins plus 1 coin. 7 plus 7 plus 1 is 15. But greedy method won't take the solution. It will only choose, it will only work for the at present situation. It will try to give the present situation best solution. Okay. So in the real time example for you in your campus, okay, when you are attending for the campus placements, when company comes, they have their own set of constraints, their own set of process, first written test and technical round, like that. Okay. So who will qualify the written test? They will be separated and remaining will be left. Okay. And then technical quiz, technical round. Okay. So those who will satisfy their constraint, that will be that candidates will be separated. Okay. So level by level we are taking the who are satisfying the given constraints, that candidates will be selected. Okay. So that is in that process they are following the greedy method only. So we cannot say the final students who have selected out of 200 they have selected only 10 members. We cannot say so those 10 members were satisfied their current time situation, their current time rounds. Okay, so written test and that what is the rounds they have conducted, they have satisfied their constraints. That's why they have selected as the best people among 200 people. Okay, that's why they have selected. But those who are left within 190, some students were there, they have more knowledge than who were selected, who are already selected for the interview. Okay, so globally we cannot say that these are the best people for selecting this company. For that, at present case, they are satisfied their constraint. At that situation, they are the best people who are selected, they are the best people. Okay, so greedy method will works for present time situation and local situations. Okay, not globally. So that is the statement here. We may conclude that, so this is the case here, we may conclude that greedy approach picks an immediate optimization solution may fail where global optimization is a major concern. Okay, so this is the greedy method. For regarding greedy method, we can say this statement. We cannot say when we have choose the greedy method solution, we have announced that this is the optimization solution. So we cannot say that this is the best solution for globally. Okay, so this is the this is the first session we have covered. Along with this one, I will cover the next topic, job sequencing with deadline. Okay.